Welcome to the Tim Booker channel, where wisdom deserves to be spread. Wishing you a pleasant listening experience. Today, I'm going to talk to you about a popular science book titled The Order of Time. This book will introduce you to some new developments in the field of quantum physics. These breakthroughs are sure to challenge your understanding of the concept of time. Our most fundamental perception of time is that it flows uniformly in one direction. But is this really the truth? Just as Earth appears flat but is actually a sphere, and the sky seems to rotate while it's actually us moving, many truths that once seemed self-evident are merely biases when seen from today's perspective. Time is no exception. Starting with Einstein, physicists have continuously discovered that time is vastly different from our perceptual experience. In fact, in a certain sense, time might not even exist. The proponent of this viewpoint is Carlo Rovelli, the author of the book. He's a renowned Italian physicist and one of the pioneers of loop quantum gravity theory. He's considered a rising star in the field of theoretical physics. He has also authored two other popular science books on physics, 7 Brief Lessons on Physics, and Reality is Not What It Seems, both of which received high praise. Some even say he's the next Stephen Hawking. Before delving into the interpretation of this book, I interviewed several theoretical physicists. They mentioned that Rovelli's research in loop quantum gravity theory is an important direction in contemporary physics research. Their goal is to address a major challenge in theoretical physics, explaining gravity using quantum physics. And in the process of solving these problems, they've discovered that time doesn't exist in the microscopic quantum world. Of course, this is a challenge for physicists to overcome. Rovelli's aim with this book isn't to help you grasp complex physics knowledge, but rather to convey the idea that modern physics has shaken many foundational and essential concepts that we once took for granted. Take time, for example, a concept we consider unquestionably fundamental to the world's laws. However, in reality, it's merely a variable arbitrarily set by humans. In this light, perhaps we need to reassess the way we understand the world around us. In today's exploration, I'll guide you through two aspects to help you reconsider the concept of time. In the first part, we'll examine how contemporary physics research, particularly Rovelli's studies in loop theory, has upended the concept of time. In the second part, we'll discuss what a quantum world without time looks like and explore why we still sense the passage of time even when it might not exist. Are you ready? Let's begin, as we're about to completely overturn our understanding of time. I'd like you to consider a question with me first. Imagine we're good friends, and I'm right beside you. If you want to know what I'm doing right now, it's simple, you just look at me, right? But what if I'm in Beijing and you're in New York? A phone call would do the trick. However, what you see and hear from me, is that truly me in this very moment? When you see me, it means you're accepting the light that traveled from me to your eyes. Light takes a bit of time to reach you, even if it's just a few nanoseconds. So, what you see isn't what I'm doing right now, but rather what I was doing a few nanoseconds ago. If you were to call me from New York, my voice reaching you would also take a few milliseconds. What you hear isn't my voice at this exact moment, but my voice from a few milliseconds ago. Makes sense, doesn't it? Of course, you might say that the gap of nanoseconds or milliseconds is so small that we don't really feel it. So, what's the significance of discussing this? But what if I were on a distant planet? Let's say, planet Bylin. It takes light 4 years to travel from me to you. If you were to observe me through a telescope, you would only see what I was doing 4 years ago. The next question then is, 4 years from now, would that version of me be in the same time as you are right now? According to Rovelli, no, and that's the truth Einstein's theory of relativity tells us. How do we explain this? In relativity, time and space cannot be discussed separately. However, when we define the concept of now, we completely neglect the factor of space and only consider time. Therefore, in this sense, there's no universal now throughout the entire universe. The extent of the now we commonly refer to depends on the precision we set. If precision is in nanoseconds, now only exists within a few meters. If in milliseconds, it expands to a few thousand kilometers. So, Rovelli likens now to the point where a rainbow touches a forest. You can see it, but it's not there when you reach it. Now is just a vague sensation that humans generate based on their experiences. Time is the same. In our experience, time flows and has direction. However, contemporary physicists have already shown that these perceptions are likely wrong. In the past, we thought time was unified. Physics and astronomy described phenomena within a unified concept of time. But this unified time is actually a human construct. Einstein told us that there's no unified time, there's a multitude of times, with each point in spacetime having its own time. Now, humanity has developed instruments more precise than traditional clocks that can measure these tiny differences in time, providing evidence for Einstein's viewpoint. If you place one instrument on the summit of the western Himalayas and another at sea level in the Indian Ocean, you'd find that time flows slower at sea level. This conclusion isn't just theoretical anymore, it's applied in real life. The time of GPS satellites is different from that on the ground due to these minute differences in time's flow speed. And this is just the beginning. If we delve deeper, we discover that time doesn't even have a direction. The irreversible past, things that can't be undone, these are our most basic understandings of the world. But to physicists, time doesn't work that way. In physics, time possesses a property called t-symmetry, where t stands for time. If you already know a planet's current position and velocity, you can use equations to calculate its future position and velocity. But in reality, you could also calculate its past position and velocity in reverse, which is the essence of t-symmetry. Since both forward and backward calculations are valid, what basis do we have to declare one direction as the future and the other as the past? Rovelli says this is the secret about time that physics equations reveal, it simply lacks a direction. So why do we perceive time to have a direction? Physicists believe that the direction of time is related to heat, due to an equation in physics known as the second law of thermodynamics. This law's essence is that heat can only flow from a higher temperature object to a lower temperature one, not the other way around. For instance, imagine you're watching a video where a small ball is rolling. You can't really distinguish whether the video is being played forward or in reverse, can you? In other words, the time in the video has no direction for you. But what if the ball comes to a stop? Then you can be sure it's not being played in reverse. This is because you know that the ball, when in motion, experiences friction, which slows it down and eventually brings it to a stop. This informs you of the direction of time for the ball. At the same time, you also know that friction generates heat. This explains how the perceived direction of time we understand is actually related to the flow of heat. You might have heard of the variable that describes the change of heat, entropy. It's because of the relationship between time and heat change that physicists speculate time's passing and the increase of entropy might be closely linked, potentially representing two different aspects of the same phenomenon. Starting from this point, Rovelli presents his most revolutionary viewpoint: time doesn't actually exist. We know that an increase in entropy represents the transition from order to disorder. So, Rovelli boldly argues that the concepts of order and disorder are fundamentally subjective judgments, not objective realities. Hence, in the universe, there isn't an increase in entropy, and there isn't an objective existence of time either. This concept might be a bit challenging to grasp, so let's take it step by step. First, let's understand why the transition from order to disorder is subjective. Rovelli provides an example in his book. Imagine you have 4 playing cards in your hand, the first 2 are red, and the last 2 are black. You would perceive these cards as orderly, right? Now shuffle the cards, mixing up the colors. The cards shift from order to disorder. But here's the catch: whether you see this change as going from order to disorder depends on your focus. What if you're focusing on the numbers? These 4 cards initially are arranged as 2, 4, 6, 1, and after shuffling, they become 6, 2, 4, 1. Neither of these numerical sequences holds particular significance to you, shuffling merely turns them from one form of disorder to another. So, is this change from order to disorder or from one disorder to another? It's determined by your subjective choice. In reality, if you consider all variables of the playing cards, whether it's color, number, or any other factor, it becomes difficult to classify shuffling as a transition from order to disorder. The universe operates similarly. The universe is undergoing changes, like shuffling, but the variables involved are much more complex than those in a deck of cards. We think the universe is moving from order to disorder because we're observing it with certain variables in mind. Certainly, we can only perceive the universe through a certain level of fuzziness. This is when you might perceive certain arrangements as orderly, see transitions from order to disorder, and believe in the increase of entropy and the existence of time. So, conversely, if we could reach a level of precision at the quantum scale, wouldn't the increase of entropy cease to exist? This implies that there's no objective existence of time in the universe. Just as we mentioned earlier, now is merely a vague sensation generated by humans based on their experiences. Time itself might also be a vague sensation generated by humans based on their experiences. This conclusion might be astonishing. Could such a clear and fundamental sensation as the passage of time truly be a result of our inability to comprehend the entirety of the world's details? Although Rovelli's arguments haven't been fully proven through experimentation, his explanations fundamentally shake our understanding of time and the world, much like when we discovered that the Earth isn't flat but rather in motion. Yet today, we all accept that the Earth is in motion, as the evidence is irrefutable. At this point, you might be curious, what does a world without time look like? Why does the passing of time feel so real to us? In the second part, let's explain these two questions. Let's accompany Rovelli and venture into a world without time to take a look. Rovelli states that the absence of time doesn't imply that everything is motionless. Even though time no longer exists, events, changes, and relationships persist in the world. His point is that regardless of the scale at which we observe, the sole constant rule is that the world is in a state of flux. In contrast to change is stasis. In our common understanding, objects are static, while events are dynamic. A stone represents a typical object, and a kiss is a typical event. I can say that the stone will still be on the mountain tomorrow, but I certainly wouldn't ask where that kiss will be tomorrow. These viewpoints are two opposing ways of perceiving the world. Throughout history, many philosophers and scientists have attempted to comprehend the world from a static perspective, viewing the world as composed of objects. Plato's work, Timaeus, portrays an absolutely static, precise, and perfect world. However, we now know that Plato was mistaken. This is largely because he chose the wrong direction, viewing the world as static. Rovelli contends that the entire course of scientific development tells us that understanding the world is about change, not stasis. The theories that unveil truth, whether Newtonian mechanics or quantum mechanics, describe change. They elucidate how events occur, not the appearance of objects. This is the approach that contemporary physics takes to understand the world, approaching the truth. The quantum world is a world of continuous change. When viewed from a quantum perspective, the world is no longer composed of objects but of events. What we perceive as objects are merely longer-lasting events within the quantum realm. Think about it, even the hardest stone is undergoing change. As far as we know now, a stone is a complex vibration in the quantum field. It can be seen as an instantaneous action of forces, a fleeting equilibrium before it crumbles and returns to the Earth. This is the world depicted for us by loop quantum theory. The world isn't composed of strong objects but of fleeting events, it cannot endure and constantly transforms. Rovelli notes that while this might not be the best accepted answer within academia, it's the only self-consistent answer he currently knows. This principle isn't difficult for ordinary people to understand. A cloud isn't an object, it's a collection of events where air moisture condenses as the wind passes over the mountains. Similarly, a person isn't an object, they are information, light, language, and a complex process of interactions, an event node within the network of emotional exchange. People are also collections of events. So, if time isn't a fundamental rule of the world, what exactly are we referring to as time? What is our watch measuring? What is that sensation of continually moving forward without ever moving back? In his later years, Einstein said, "People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion." Many people quote this line, assuming Einstein was discussing the nature of time in physics. However, Rovelli argues that people have misunderstood Einstein's intention. Einstein's words were directed to his good friend's sister because his friend had recently passed away. Preceding that quote, Einstein mentioned, "Now he has departed from this strange world a little ahead of me. That signifies nothing." Then he continued with the famous line about the illusion of past, present, and future. With the context, you can understand that Einstein wasn't referring to the physics understanding of time, he was expressing his sentiment about life. Life is fragile, fleeting, and full of illusions. Rovelli adds that this statement delves deeper than physics itself. Einstein's underlying message is that time arises because of us. We can see clouds in the sky, a teacup in front of us, or a cat sleeping in the sunlight. Yet, if we revert to the quantum scale, there are no cats, no teacups, and no clouds. Everything is due to us observing this world revealing itself to us. The emergence of time from a world without time is also due to us. Why is this the case? As we mentioned before, the flow of time is related to the increase of entropy. Entropy is a relative measure, much like velocity, it necessitates a reference frame. When you say a train is fast, you have something slower in mind for comparison, perhaps another train or the platform of a train station. Likewise, entropy growth isn't a state of the world itself, but a state relative to us. In our perception, the distant past represents a world with low entropy, so the world appears to be in a process of entropy increase. Hence, everything seems to transition from order to disorder, giving rise to the concepts of the past and the future. This is merely one way of describing the world, a way we have chosen. Please recall the example of the playing cards I mentioned earlier, and this principle will be easier to understand. The world we inhabit is likely just a sublevel within the universe. Within this sublevel, we observe the colors of playing cards, a specific rule known as entropy increase. Thus, we believe that the past had low entropy, enabling the second law of thermodynamics to hold, leading to evolution, life, and thought. Lastly, let me share a prophetic story with you to delve into the deeper significance of this conclusion. There was a king who asked a sage, "Master, what is your name?" The sage replied, "Your Majesty, I am called Na-Sien." Na-Sien is a name, a term, an appellation, a symbol, and within it, there is no individual. The king was astonished and retorted, "If there is no individual, then who is wearing clothes here and eating food?" He continued, "Is the hair Na-Sien? Is the name Na-Sien? Is the feeling Na-Sien?" The sage replied, "None of these." It seemed as though the king had won the argument. If none of these components are Na-Sien, then Na-Sien must be something else, likely the person standing before us. However, the sage countered, "Is the wheel the chariot? Is the axle the chariot? Is the chariot the sum of these parts?" The king replied, "Certainly, the chariot is both the wheel and axle, an integrated whole, and their relationship." You see, Na-Sien triumphed. The name Na-Sien is simply a collection of relationships and events. So, what constitutes the unity of a person? Why do we perceive today's self, yesterday's self, and tomorrow's self as the same person? Philosophers and psychologists have already informed us of a crucial reason: memory. What is memory? Memory is the consolidation of information scattered across time, a way the brain processes information. Recent neurobiology research has discovered a fundamental structure within the brain. It records not momentary phenomena but the process of motion. When a ball appears in one position and then in another, the brain doesn't receive two distinct signals, it receives one signal. It's akin to listening to a musical note, your brain combines the preceding and following notes to comprehend the melody. In other words, the brain isn't taking photographs, it's recording short videos. Disney's animated film, Inside Out, vividly portrays this mechanism. In this film, memories stored in your brain are segmental, each encapsulated within a beautiful glass sphere. A touch is like pressing the play button on a miniature video. When memory activates, it inherently includes time. Hence, regarding time, Rovelli's ultimate conclusion is that time isn't a fundamental law of the world but arises because us humans observe the world from a specific subset and perspective. In this book, Rovelli repeatedly references the advice the sage gave to King Oedipus: "Stop, don't investigate further, otherwise, you'll find yourself." In this pursuit of understanding time, we ultimately find ourselves. Alright, we have concluded discussing the book, The Order of Time. Now, let me summarize. Contemporary physics has overturned the concept of time. Time is neither uniform nor directional. In the microcosmic quantum world, it might not even exist at all. Time isn't a fundamental law of the world, rather, it's a variable that manifests when humans observe the world from a specific perspective. In this book, Rovelli, to convey his viewpoint, must inevitably simplify many complex theories. Indeed, this book isn't a rigorous physics work. Perhaps we should view it as a book that uses physics as a starting point to inspire philosophical contemplation. It will inspire you to ponder, what is the essence of time? How should we perceive our ways of understanding the world? In the book's conclusion, Rovelli writes, I am not the body that sits on the sofa typing on the computer right now. I am my thoughts, my loves, my despair. I am the person who made tea for himself a minute ago. I am the person who is writing this sentence that is being completed just now. If all this were to vanish, would I still be here? My life is made up of this. We are stories, complex places 20 centimeters behind the eyes, lines drawn by the traces left by things mixed together, pointing toward the direction of increasing entropy, toward future time. The above is the essence of this book. Congratulations, you've listened to another book. Thank you for your support and attention. Please subscribe to Tim Booker's audiobook channel. Like and share with family and friends, wisdom is worth spreading. Open up to a brighter future. Thank you and goodbye.